we took a look at this in the last video, the limit of the difference quotient as h approaches 0. Now, formally, what we call this in calculus is called the derivative. And we can express the derivative as f prime of x. This little asterisk marks that we apply here denotes that we're trying to find the derivative of x. And the derivative of x is just what we did in the last video, is finding the limit of the difference quotient. And the derivative basically, there's two things that we want to kind of remember about the derivative. The first thing is that it's kind of a formula for slope of a function. So we have any function f of x, and the derivative basically just gives us a formula for the slope at any point. So we can use the derivative to find the slope of the particular function at any given x value. So what we have here, over here, we have the f prime, which denotes that we're trying to find the derivative. And another way to express that we want to find the derivative is writing it like this: d over dx of f of x denotes that we're trying to find the derivative of f of x with respect to x. So we have the x here, saying that we want to find the derivative of f of x with respect to x. Now we can also find the derivative with respect to y, and that's not too common, but that'll be expressed as d of y over d of x of f of x. And that just basically means that we want to find the derivative of y with respect to x. So we want to find how y changes, how the slope of the y output changes with respect to the input. Now we're going to get a couple types of problems here, but we're going to explore the first one in this video, and then we'll take a look at a more complex problem in the next video. But we want to find the derivative of a function. So we want to find f prime of x of root x plus 1. And the way we're just going to do that, we're just going to use the limit process to find the derivative. So we want to find the limit as h approaches 0 of root of x plus h plus 1 minus the root of x plus 1 all over h. And we want to simplify this because we cannot use direct substitution. And since we do have a kind of a root thing here, we can simplify and then use the conjugate. So this, we can distribute the negative over, and we can get the 1 minus 1. Those cancel out. So we're left with root of x plus h minus root of x over h. We multiply by the conjugate root x plus h plus root x over root x plus h plus root x. And again, remember, this means that it's equal to 1, because anything over anything is really equal to 1. So now, if we do this, we get a squared minus b squared. So we essentially just get x plus h, because the squares and the square roots kind of cancel each other out, minus x over h times the quantity of root x plus h plus root x. X minus h, x minus x equals 0, h over h is equal to 1. So now we just have 1 over root x plus h plus root x. But we are not done yet. We want to find the limit as h approaches 0. So limit as h approaches 0. And now we can use direct substitution without getting the indeterminate form. So that's what we're going to do. We're going to do 1 over root x plus 0 plus root x, which is equal to 1 over root x plus root x, which means that equal to 1 over 2 root x. And this is going to be our derivative, our little formula that tells us the slope for every x value.